Tasari, and I will serve as moderator within 1.5 hours to give an overview of what will be discussed. We will cover the course on spatial decision support system held by Fakulty Geografi Universitas Muhammadiyah Surakarta. So, without any further ado, please welcome Dr. Mian.
Thank you so much for introducing me. This is for me. Assalamu alaikum. How many of you have heard this term in GIS? Uncertainty. Spatial uncertainty. Show me hand if you have heard this term before. No? What do you mean by, okay, leave it. What we think, what is certain. If we are sure about something, it's all right, it's going to happen. Like I'm going to deliver a lecture now. And you have to listen to me for next half an hour somehow. Don't sleep, okay? Listen to me. So you are certain, I'm going to do something, you are going to attend something is certain. Uncertainty, the thing we don't know. Sometimes we don't know. What I want to tell you today, in GIS, in Geographic Information System, and in spatial sciences, and in spatial information technical sides of the studies, we don't know so many things. Anything related to spatial we don't know is called spatial uncertainty. You are not late. You are not late. Okay. So only thing you have to do, respond to my Assalamu alaikum. Yes. Okay. So let me start. So what I'm going to do today, number one, I will set the context, and your pointer is not working. Your pointer is not working. Your pointer is not working. It's working now. It's working now. Okay. No working. It should work with me. Okay. What I'm going to do today, but it's working. I'll set the context first. So part A, to tell you few definitions, few meaning, few semantics. Part A is what I do, what is uncertainty, and I talk about the related terms so we understand what I'm going to tell you today. I'm leaving a message actually. We think maps and GIS is all good, all correct, all perfect, particularly the GIS specialist. They think it's perfect. No, it's not. There's something wrong with GIS. We don't touch that. I'm lecturer in GIS, but it's the other side of the coin. So we should know what is wrong, what is not there. So I will talk about accuracy and uncertainty. We understand the basic concept. I will talk about then geographical information. So you are all geographers. We should know what is geographical information, how we geographical information, what does this mean? What is the advantage, how we use that? So I'll talk about geographical information, and then what is uncertain in geographical information, what is not right, what we don't know in geographical information, that I want that you should know today what we don't know. As a specialist, as a GIS specialist, as a scientist, we don't know so many things still. So GIS is still growing. So I want to tell you that that is uncertainty for me. Okay. Part B, that is my focus. How we can tell to others in GIS world which we don't know. That is communication of spatial uncertainty. I will end with this. Okay. Let me start with. And I need your kind attention to listen to this gentleman. He's a guru on spatial uncertainty. It's a short video. Listen carefully. I need your kind attention. What does he say about maps? You are okay with the volume? Volume up. Volume up. The same thing happened yesterday with me, and the context will change. There is volume button up. Okay, hold down. No problem. It's me talking there. The video should be on. All right. Hold down. No problem. I have to do this. I have to do this. Okay, by the time he is fixing, tell me one thing. If dad call you today and ask you, where are you? What will be your response? Where are you? Where are you now? Geography, you don't south 110-degree this. You tell I am in it's a place. It's a place, and in GIS word is called proximity. So how we talk, how we communicate is a place and with reference to place. But if you tell mom or dad I'm at 110.5 degree and 111.2 degree east, south and east, they will don't understand. GIS whole world is developed on coordinates.
General principles.
It tells you any question, it answers you any question in the coordinates. And coordinates are not perfect.
There cannot be a perfect map.
That is uncertainty. Okay, so now a new type of GIS coming that is called Spatial GIS. I hope I can write with the pen. I hope I can write. So what we have is Spatial
subject to uncertainty.
GIS. Okay.
Moreover,
What we have is Spatial GIS. Is lat, is long, is coordinate. So we divide our coordinate. We have an undefined center of Earth. And based on that, we have imaginary lines called latitude, longitude. So GIS is based on these coordinate systems. The geography maps are based on these coordinate projection system like this, okay? And we don't know exact what is the position of Earth. Believe me, we estimate based on, we just estimate based on magnetic field, shape of Earth, defining ellipsoid using mathematical model, geometrical model. We exactly don't know. That's why we are defining, redefining. We have WGS 60, then we have WGS 62, then we have WGS 72, then we have WGS 84. Have you heard about WGS 84? Now using WGS 84, what are these? We are readjusting these coordinate system because we try to define position of the surface of Earth, the perfection, right? But we are not successful, and we won't, because this whole Earth is changing. It's dynamic, it's drifting, it's changing. So lat long. Now I give you another example. Here is Dr. Farah at the corner. It's me, Dr. Nawaz. What is the difference between me and Farah? Guess 2.5 meter. Okay. Yeah. We can have something put there, state 2.5 meter. Measure 3 times. 1, 2, 3. Take it. Now you ask this question to GIS. Ask this to GIS. What is the difference between Dr. Farah and me? GIS will start like this. My coordinate, let 110.516 south, 112.3510 east, and then it's me, it's Nawaz, then Farah will take whole coordinate system, analyze, give answer, plus minus maybe 100 meter, we are 2.5 meter away. So plus minus 100 meter. Makes sense. Do you follow this? Do you understand this? This is spatial. This is spatial space coordinate system and working. Don't think because we haven't defined Earth properly. We are struggling with WGS. All this now we have WGS, or maybe tomorrow we have another. We don't know the absolute value. We don't know. That's the issue. So that's gentleman was telling that there's no perfect map, and GIS we have a lot of discrepancy. Are you with me? Thank you. Thank you so much. If you understand this, doing with GIS is lot of uncertainty. Coordinate are not perfect. Getting on from the location GPS, you know, GPS coordinate comes in. There are algorithms that keep fixing all these coordinate plus minus and putting you onto the right road almost. That's how it is working. So there are a lot of algorithms working. You have to fix and refix a lot of to use these coordinates, but we don't understand because we are just all the time. What is the technology? What's the algorithm? What's happening? We don't understand. All right, let me move forward. Next slide, please. Take this from me. It's not working. Okay. One step back. All right. How many have learned statistics or from statistics? Statisticians. I know one statistician is there who got statistics, bachelor's in statistics. Okay, what are you? All right. Is there any true value? What the true value means? You go to the field, you measure, you measure the things. You are sick, you measure your temperature. This measurement, you take measurements. Thermometer is never correct. It's always something plus minus. Click next. You sleep, okay? I'll keep doing. All right. So true value is something that we can exactly measure correctly, absolutely correct. Do you agree? True means true. But what we measure, now come to the GIS, special word, what we measure based on coordinate and projection systems. They're not perfect. No. So in GIS, measuring a true value, is it possible? No, it's not possible. So what we take in GIS true value is either calculated or estimated value we live with. And we never think when we are learning GIS. When we are geography, we never think. Projection, coordinate system, we live with calculated or estimated value. But if we come, the life easier. Easy to do like this, that you have one measurement, 99 meter, another measurement, you take an average. Yes, you can define and you can see, okay, here plus minus 5 is uncertainty, and normally we symbolize like this. So a number of readings, we say uncertainty is 5% in that data value. Are you okay? So in statistics, it's possible. In statistics, how we take it. Now you come to the GIS word. It's position, it's vertical position, it's horizontal position, it's X, Y, Z, and our true values are not there, estimated values with lot of uncertainty. Does this make sense in GIS? No, when we have position in GIS, it's all uncertain, and that uncertainty is always an issue. But I was revise some high school definitions. It's not GIS. It's not GIS just revising. We know if we increase trueness, and most of the cases, the true value is the estimated value. And in GIS, always this estimated value. Coordinates are estimated. For position base, coordinates are estimated, then everything on is estimated. You okay with this? Everything is estimated. So if estimated value you take as a true value, that's y-axis, and this x-axis is precision. When we increase accuracy, certainty goes down. That's what we know at. But we can go through and we can revise. It's always good to revise. So for me, accuracy is closeness of agreement between the true value or estimated value. So you decide, you go with the estimated value or you use the true value. True value is not there, so you go with the estimated values. That is accuracy. And precision is something like this. But sometimes we got error. If we go away from the precise position, that is a touch screen. I shouldn't touch it. Where's my freedom of teaching? So I now realize touch screen. It's okay. I will manage. Don't worry. Now I know it's touch screen. I will manage. Take it. You take rest. I will manage. Okay. So it's the difference. If there's an estimated or true value, it's the difference of true value is error. We make so many errors when we work. We can handle the error. No problem at all. And precision is hitting the same point again and again, something like that, close. It can be like, it can be right or wrong, but precision is something hitting at the same place again and again. And trueness. Who is going to find trueness? True value, not available. So trueness is the closeness between the agreed or average value. When the values are close with you, or got high truth. Truth, absolute truth? No. That's what statistics, GIS, all algorithms say. So there is only one truth. That's it. No algorithm, statistics, all these things are just wrong thing. And then we come to the uncertainty. So what is ambiguity? What is the problem doing all this? We don't know, that we name as a uncertainty. Now we come to the GIS word, because you are geography and GIS. Back to GIS word. All right? You have heard about spatial data accuracy. So we revise what is accuracy. Now you can think, what is spatial data accuracy? It's the same like accuracy. It's the closeness of observation, what we make in GIS, to the truth. And when you say GIS is position, lot, long, Z, they are not true. So estimated, close to estimated, or true value or estimated value, that is spatial data accuracy. So we know that we can have a very accurate spatial data, but still we can identify something in spatial data that is called error if you do something wrong or you make a mistake. So the degree to the level you make a mistake, that is known as, you can do digitizing, mirroring, doing this and that, and you can fix that. But then what is uncertainty? What I want to tell you today, what is uncertainty? Nobody will tell you. You haven't heard before. should know it's a merging field in GIS. If you touch this, you go so high. I'm touching this. Nobody listen to me because it's complicated. It's dry. Okay? But I try to communicate through on you. I want to teach you precisely. So for me, uncertainty is the lack of knowledge about error. You make error, but when you don't know what is the error, what is the level of error you made, that is uncertainty. Try to pick this, and it's a lot in GIS world. Are you okay with this? Don't try to memorize this definition at any stage. I give you one example. Have you ever digitized a map? Who has digitized the map? Okay, how we start digitizing map? We have a base map, we have a satellite image, we geo-reference image, tick coordinate, click, click, other point, click. But what about the base map? What is the base of base map? Base of map is some coordinate system saying untrue, estimate, uncertain values from the coordinate system there. So, what we do, we click, we find the difference, error distance we can find, we can match, we can digitize. So, digitize geo-reference curriculum, and we can lower the distance, we can correct all this. Now, tell me what exactly what we're doing when we're fixing our errors. We are fixing simply the errors. Okay? The uncertainty, we don't touch it, we don't know. We never knew. When I was learning this, I never did something more to do. So what we do, based on that, we have geo-reference. This is the point. This point in base map is there. Hold it close, bring it, geo-reference. Now the image is perfect for use. We use it, we find values, we can do all things, but still we miss one thing, the lack of the level of knowledge that we don't know how uncertain, where it is, or what is the difference is. So, particularly what we are doing in GIS. This is what we are doing in GIS. Ego. What's a ego? Salto do amiga. I will count 1 to 3. What we're doing in GIS? Ego. Garbage in, garbage out. I'm sorry to say, being GIS specialist, when I first time heard this stuff, I was not easy, I was not happy. I got my master's in GIS, I trained in GIS, doing special this and that. Then I realized, no, it's true because I didn't know when I was doing. So I was doing all the time with this uncertainty, all these things. When we were doing end of special data, now I think why garbage in garbage. So spatial data basically, when you talk about spatial data, it's an abstraction of what? Abstraction of location is critical, and we take location as a critical attribute in spatial data. It's one attribute of the data. It's one attribute of the spatial object. Location is also an attribute. Okay, based on that, we measure the location. And when based on measurement is not right, how you find the true value? Impossible. So if we create geographic information, you define features, phenomena on the earth. And let me remind you of more terms related to geographic information. Normally use geographic, spatial, geospatial, all these terms. Have you heard this term? Geographical information, geospatial information, spatial information, and these terms are like interchangeable terms. They mean the same thing. We are talking about geographical things. So they are different terms, but they mean their purpose to use this term in India is the same. So we convert spatial data into spatial information. Measurement points is the data. You visualize in the form of maps. You create on top of a system, a support system. You enhance added value to the information now for somebody to make a decision. But when it's uncertain, it makes a mess. So you start doing complex reality. I am in Seoul. I'm going around the roads and all this thing. I'm looking all the time outside. It's a beautiful city. Very bright people, lovely people. You say Assalamu alaikum and they loudly respond to you. Oh, alaikum salam wa rahmatullahi wa barakatuh. What I see around me, can I see all that on the map? No. What will be on the map? Few things out of the other. So maps are very clean and abstracted version of the real world. We make certain themes, parcel, boundary, and very big. Okay? Okay, so you extract out of this and then you create something that you need, what is your project, what is your purpose. That's what you do with this spatial information. So reality is very complex. What is in the database is abstract. Got this point? It's not all, it's less than all. And for doing this, we do a lot of approximation. We approximate, we don't exactly bring everything according to scale. But put something according to what does it mean? It's approximation. When you approximate, you further add uncertainty. So this is a real world. When you move from real world to first level, digitizing, bringing to the system, that's U1, you conceptualize. That is called spatial modeling. So spatial modeling is doing digitizing, simplifying the reality, and bringing into the system. You bring in, then you present. You develop your data, then you present. You do a big map or 3D presentation or something in GIS. It's another level of uncertainty you add. So you one is one level of you do, and then you analyze when you do the analysis, because already uncertainty is getting great, research is increased. On top of that, you develop a spatial distance sports system. I developed one in 1998, South Sulawesi, Tanah Toraja, Indonesia. I'm not near Indonesia. How many of you have gone to the Tanah Toraja, Sulawesi, Indonesia? Is correct pronunciation? South Sulawesi, Indonesia, Tanah Toraja. I developed a spatial distance system for land use planning for South Sulawesi in 1998. Some of you have not born. Alright? But what at that time I realize I induce uncertainty here and at another level, and this by distance food system was very uncertain. Worked, but it was not right. It was useful, but it was not right. That's what I want to tell you. We can handle uncertainty. We can handle uncertainty if you try to understand the uncertainty. There are different levels of understanding uncertainty. If some of you are interested, I can really guide you. That's level of uncertainty in positioning, in description, in conceptual, and in meta uncertainty. Type of uncertainty. So the field is developing in areas. You start working on one, or you take another mode if you are quite intellectual and philosophical mind, nature and source of uncertainty. Go for epistemic or ontological uncertainty. Like there's certain philosophical thing related to this, how to define a spatial. how to name and define, how to attribute that spatial element, and or you can go to the modeling side of uncertainty. It's a really, really new and developing field in GIS. So epistemic is all related to knowledge. Ontological is all related to existence, position, and all these things. And it can be, you can go even for ambiguity. What is ambiguous here, what is not understood here. That is another field in GIS. Or all probability theory statistics that is developed in the right now, including probability theory, set model, upset theory, and fuzzy set theory, all are applicable. They are dealing with spatial uncertainty, GIS, for statistics, and background. It's a pure field for you to understand and do. Let me make your life easy. How it works, what I was saying. It all in here, what I'm saying, let's see in practical. I'm Australian citizen, I'm from Australia. We live, where we live? Down at the top end. Yeah, in the top end, somewhere here. There's the TV icon somewhere here. In this solution, have somewhere here. Our house there, okay? And this is very easy to understand. Don't need your address. Easy, relax. Look at this example. We define based on WDS 84 judicial marks 1, 2, 3, 4, 5, 6. You may have seen near follow somewhere the stone. They put the stone in the ground and right attitude longitude. Have you seen one? It's a point on the earth where coordinates are. Okay, and there will be many around all over Indonesia. So we put 1, 2, 3, 4, 5, 6, 7, 8. According to WTS 84, based on GPS, we knew that these marks are plus minus 2 centimeters. So based on GPS readings, we define this Australian judicial network plus minus 2 centimeters. That means we are not sure. So this latitude longitude distribution is plus minus 2 centimeters. Based on this judicial marks, we define Australian national network. So based on these judicial marks, we have Australian at these points are there. When we go from there to further Australian national network, further stone we put, we know it's no more 2 plus minus 3, it's more than that, plus minus 5, 6. So, in early 80s and 70s, Australians did a lot of work putting stone on the ground, writing coordinate, writing that this is plus minus 2 centimeters, and this every stone here has plus minus 5 and 6, or whatever. Okay, what's happening with Australia? Look at this now. What's happening with Australia? This whole plate, tectonic plate, is moving towards northeast, 1.8 meter, 1.8 centimeter per year, 1.6, 1.5, 1.8. That means it's not only going towards northeast, it's 1.8, 1.5, 1.5 means it's also rotating little bit. Does it give an idea? 1.5 on this side and 1.8 on this side. So it's moving toward this direction, and then it's more on the left side. So and now we are feeling on and off earthquakes. I live in Singapore, so talking to Farah, she will tell me, "Oh, earthquake, words come out all of a sudden," because that's what happening. So it's not only moving toward northeast; it's rotating. What the hell we will do WTS 64 stone mass, digital network, and all this? They all change. And these are all estimated values. We don't know exactly if it is 1.6. It's plus minus something. 1.5 is plus minus anything. Do you understand? GIS word is not anything word. So everything was spatial uncertainty. We are not certain what it will do if continent move. Where the distribution network and all. So if we put the stone, we know the line that has moved. Now GPS reading is moving. Yeah, we can just estimate. So with estimated values, that's what happened in Australia. By the way, because it's a movie, so we have to refix all these things. And positional uncertainty is beyond our control. Because change of movement of tectonic plate changes everything. Rotational, directional movement changes. We don't know what will happen. How? We can say, we thought for some time when our learned areas was so perfect. We are born to do this. We are born to. If I tell you today that all maths are wrong, you will not believe me. You should not believe me because right from primary school, we know it's a math. Here is Australia, here is Rosso, here is Jakarta, all these things, but they are changing. So, what the Gorgon child in video that we couldn't display was saying these things. All maps we have, and I repeat, I'm saying all, underline all maps we have are wrong. How do you feel? We are trying 3D world to project on 2D map with the help of Mercator's projection, this projection, that projection, what the hell we see Australia on Mercator's projection world map and Greenland is smaller map than Australia. We see it a bigger than Australia. Australia is a huge one. It's because of projection it looks small. So Monument is a well-known cartographer. He says it's not easy to lie back, it's a set. So all maps lie. No truth in maps. But they're workable. They give us a position, something. So we are using them, and an accurate map must tell a lie. If a map has a lie, how it can? No, they are not accurate. Our spatial databases are not accurate. Yeah, they are workable, that's another thing. And that is something that we call spatial uncertainty for years and years. I started learning GIS in 1996 or 7. No idea at that time about this. Oh, I'm old and teaching. I've taught so many students. Now I tell, and the new GIS specialist sometimes get angry with me. So what we did, how we started. Our historical view of the GIS specialist was uncertainty we didn't acknowledge and understand. Like all these things, we presented GIS as a perfect and cartographer presented map as map are not perfect, spatial data is not perfect. Wrong. So many things. Now we try to tell that there's something wrong. And then we start slowly, a sort of negative impact towards humanity. There was a, like in the early 70s, 80s, there was a view. Late 90s, we start realizing, no, something important. And now we take it important. It's not only me, it's some other prof in the world they are teaching, be careful of uncertainty. Be careful of uncertainty, communicate uncertainty, think of uncertainty, otherwise you will be misguiding the decision maker, you will be misguiding your project, your all things what you're applying because the more people be careful of this uncertainty. That's now we started. If you want to learn more about uncertainty, that's the link I will be just having you. Pay attention to these two slides carefully, okay? And if you got a chance, other 4 slides I read there about 40 slides there, and it's a YouTube video. Listen to this gentleman for 45 minutes. It will open your eyes that, what's the wrong we are doing with GIS, what we have not done with the, all this.
Uncertainty, because I hope I've established that uncertainty is a big problem.
No? Okay. So, recently, In GIS world, we start trying to communicate that how much uncertainty is in our work. How is that? Of course, we start using cartographic views, but technically, because there are multiple interpretations and it's a multidisciplinary role, and comprehending all these parameters is not easy. But this is the something. If you want to shine in GIS world, it is something you should start. This is something developing in GIS that you should do. So how we start conceptualizing? We have started thinking about what is this? What is inconsistency? What is error? Is the what uncertainty? How it affects the decision? So there's something going on, and how we started communicating. Now in 3D map, we see when there is an uncertain map, we just blurring you understand. And this concept is very old. You know this chart, valuable separation. We make use of this. You can have a map. In map where you are not sure that is all when it's that blind. So the map was not like this. But now, with uncertainty communication, we saw in the new maps. And we have started doing something more. Come on. Okay. Glitch. Like it's not animations we can create now, and those animations will give the uncertainty. Here you see in this particular animation, it's a magnitude and uncertainty in the direction of air. You tell a direction, but when you're uncertain, you make them small or give a different type of base color that when you look visualize, you know that something we don't know. So the lack of understanding. Here another example. Red for uncertain areas and blue for certain areas. So we can use some color. Does this make sense? If you're not doing cooking, you're not sure, you can communicate that I'm sure we are not sure color use all animation or with this sort of graphs plus minus bars on the map, or you can use the another tool that like dynamic representation and animation nowadays. So here you see the slope stability. The more stable slopes are in brown color. The less stable slopes give a different color. So it's not impossible when you don't know the lack of knowledge you bring. Just don't make whatever you have done, make it perfect. Change perfect. Communicate to the user that yeah, there's a problem, but they're not doing that. Because it's not only cartography, it's not only EIS, it's mathematics, statistics, other algorithms, multidisciplinary thing. So you have to learn a lot. Understanding component itself is a whole new area that how we understand uncertainty and how we use that knowledge, and if we understand that, how we visualize that. These are all learning steps and these are all developing areas and developing representation, all this in uncertainty. I hope we got part of it. 30 to 40%, okay, not 100%. But we know at least maps are not perfect. Spatial data is not perfect. And as a GI specialist, it's our responsibility telling them, here I'm sure, here I'm not sure. Blurring, representing, giving color is our responsibility. Don't do the wrong things and pretend that are right. No, never. It's not fair. Allah won't tell you to do this. So you can have a reward while doing that. That's what our is. Okay. So for sure, spatial or geospatial uncertainty is a nuisance. Nuisance. The boy, the child that always make a trouble in houses for nuisance. So it's a something in GIS we're making a nuisance. It's a trouble. And we have to deal with this uncertainty. We haven't done GIS, we haven't done this. So understanding the scientific definition, understanding insanity is important. That is so important. And geospatial uncertainty, we should try to communicate whenever we do the GIS work. We should not avoid, we should tell, we should not ignore it. Okay? When you start doing working, you should know the source, what is the discrepancy. It's true for anything you do. Okay? Now I check with common sense. Get ready. And I will count Sato Dua. Carefully look at this picture. Get ready. Get ready. It's your test. It's your test. Do you think it's a real? Do you think it's a real? If you were in my lecture yesterday, don't know anything. Keep quiet, please. If you were in my lecture yesterday, keep quiet. Do you think this is real? Hello? It's not for those who were in my lecture yesterday. It's a picture from a camera. It's a picture from a camera. Is it possible? This boulder really looks like hanging on top of it, above the surface. So define all the principles. Okay? A big push to Newton's law of gravitation. Is it like that? What is actually this? Carefully use common sense again. Okay, use common sense. This. You understand? It's the boulder in the lake and it's a reflection and it will other way around. Do you think this is uncertainty? Hello? Do you think this is uncertainty? If yes, you haven't learned anything, this is misunderstanding. This is not uncertainty, this is misunderstanding. It's total misunderstanding because we misunderstood this. Picture was other way around. I put it this. It was real, now I can. Okay. So it was real, but the other way around. This is misunderstanding. What I taught you is not, I was not teaching you misunderstanding. I was teaching uncertainty. So, uncertainty is different from misunderstanding. Misunderstanding cause huge errors and errors. But uncertainty and misunderstanding is a failure when we fail to understand correctly. We fail to understand correctly. We fail to misunderstanding. But when you say uncertainty, it's not misunderstanding. It's the lack of knowledge or maybe error. It's something that we don't know. Rotating, moving. We exactly don't know, we have some estimated values. We exactly don't know how the plane moves. So lack of knowledge is uncertainty. And that's what you should touch in GIS. We want to feed in the decision makers, to policy makers, for development projects, all these things. That you should understand that what is the lack, what is the missing thing in your database, what you don't know. And if you can quantify that you don't know, that is handling the misunderstanding. Thank you so much. If you want to learn more, go for that. Please pass on these slides and watch these videos. I'm sure you will enjoy it. And there's another video for you. So you can learn more about uncertainty. This is the right time to learn about uncertainty and develop yourself as a strong GIS specialist, GIS tool. Okay? It's okay to do the spatial data visualization and spatial database management system and spatial skills board. For me, spatial skills traditional thing now. Okay? For me, because I did this at BTS to South Coast in Tamil But yeah, if you have several SDs that work well, wonderful too, it helps. It helps a lot, but you should have an idea of the answer and let me think. The new sense in this game. Thank you so much. Any questions?
Okay, thank you so much, Dr. Nawas, for your great presentation. So, anyone, maybe we'll have a question for Dr. Nawas. Please raise your hand. Okay. Ada yang mau bertanya?
One question, please.
One question.
Is there anything in this lecture you like? Any one thing you like? You like the whole? Thank you. Thank you. All right. Try. What is the question answer? Okay. And try to think. By the way, your solo is sinking and moving is as well environment here as well. Okay. You may need to find your joy and your resilience in the next step to you. Have a good.
Thank you.
Selamat.
Selamat siang. Okay, anyone? No one will give a question? Maybe? Bashar?
Okay.
Just put that I can see that.
Yes. Let me see. Yes. Tes. Okay. Tes. Okay. Thank you.
It's like a long.
Okay. Okay. I want to ask if yes. Okay. Okay. Di sini. Uh, the apa attendee ya coordinate always attendee because to plate movement, for example, how I can you how I can measure area with uncertainty area.
Thank you so much. It depends. Depends upon if it's a large scale, you can make somebody better. But it doesn't mean that they're going to be uncertain. It's always uncertain because you make all the measurement based on coordinates. And coordinates are uncertain. We accept too many of the coordinates we don't know. Just define a measuring line policy. We have known that they are all measuring because Earth is dynamic changing. GPS reading, GPS is based on ellipsoid defined of the Earth and defined cylinders that changing day and night as a defined magnetic field of the Earth that is varying with temperature. With cylinder plus or minus you can measure the area. What we have not done so far even added the information that how much that's we should add with that. That's what I told. You can make the events, but you should know that the events are not right. There's plus minus, then you should try to quantify what is not known. Then you make have to present the math with special, then you communicate answer that. Otherwise, first you have to understand what it is. So you can make amendments. We are making amendments. We have all estimated things that it's working. We are doing all these things with that. It's working. We didn't know it's not perfect. We should know it's not perfect. And that imperfection, if we can communicate, that's our point of view. When we talk about spatial uncertainty, yes, communicate that we can quantify that we don't know. We don't know what to send about, we should communicate. Plus minus. That's why you can change all the time. We have after 10 years, we won't be using this. Without changing, we have new ready system, we have to work with that. And by that time, we have to react all the positions that we have previous time. Even don't worry, in future you have to change your time zone. You have to change your deadlines, everything will be changed. Right? Because the earth drifting is going on. That is what on you. And yesterday, I think I gave an example that 250 million is for Kuala Lumpur and Singapore for 3,500 kilometers apart. How much is the distance between Kuala Lumpur and Singapore? Nobody answered. 60 kilometers? It's not 2,500. What happened? The ocean subducted and Kuala Lumpur and Singapore. We mapped now because it's slow thing. It's slow to work, but in the long run, that is a concept. Then all things are relevant from concept. I hope I answered you.
Thank you so much. Anyone else?
Will ask you about I think spatial uncertainty. I think every place different spatial uncertainty. I think in Indonesia, Australia, and it's different. My question, is it possible that we find our projection in every region maybe to minimize spatial uncertainty? Yeah.
Right of Australia is almost moving is 1.6 estimated. And other is not only in north, drifting around. Same is happening everywhere. Projection system, you develop projection system based on coordinates. The coordinates are changing their projection system are definitely defining for smaller area projections. You're right, should work. And we have bring into the change the scale of projections that may solve some answer, but we won't get rid of uncertainty. But we can reduce by take a course. That's a good idea. We can reduce uncertainty by changing the scale of project. But it's not absolute. And so is the inherently speculative. Don't raise that we are that kind of feelings. We can yes and no, or reading the map or taking that into that is the beauty that only we know that something we do everything. When we make a project for somebody who like because when you do when you produce a product in AIS, it's going for a special thinking, special policy management or something. It's proper to communicate that what is not known in your data. Rather than being specialist, proud of your software product and your books. That's great. No, that's embrace that. Yes.
Okay, thank you. Maybe anyone else would like a students? No? Let's.
Okay. Last one. Could you please start doing this, teaching yourself and students? There's something wrong with this. That's when you know you're doing so many good things, but we need to do. Thank you so much.
Yeah, thank you so much for please before. Okay, thank you so much, Dr. Nawas, for answer and for sharing your knowledge and experience with us. I'm sure not only myself but also audience gain a lot of valuable insight from you today. Okay, for me, it's enough. We have a break for 5 until 10 minutes. Yeah. After that, we have another session with Dr. Farah Satar and will be self-moderator with Pak Danardono. Okay, for me, thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you.